All right, so we're going to continue working with right triangles, and we're going to continue working with similar right triangles. So these two triangles, triangle ABC and triangle XYZ, are similar for our purposes. Um, what we've been doing is comparing the side lengths. So we've been comparing things like the length of side A over the length of side X, and we've been setting it equal to the length of side B over the length of side y. And we've set up proportions like this. And we've also done things with the hypotenuse, so we could also use c over z here. And that works out great if you have two triangles, but you're not always going to have two. Sometimes you're just going to have one. So we're going to come up with a way to use these same ratios, but use them only when there's one triangle. So the first thing we need to do is adjust these ratios, and we're just going to use algebra to do that. I'm going to adjust them so that each one is specific to one triangle. And I'll show you what I mean by that. I'm going to take a over x, and I'm going to set it equal to c over z. Okay, so once I have this, you know that I can cross multiply this, and I get a z equals cx. What I want to do here is get the c over on this side, so that I have the a and the c from one triangle as part of the same ratio. So to do that, I'm just going to divide both sides by c. Okay, on the right side, it just goes away. So on the left side, I have az over c equals x. And I still have that z in the way. I don't really want that there. So to get rid of that z, I'm going to divide both sides by z. And I already have a division bar here, so I can just throw that z underneath there. Those will go away. And I'm going to be left with a over c equals x over z. And if you look back up here, that just says that this side that's opposite from angle A, divided by the hypotenuse, equals this side that's opposite from angle X, divided by this hypotenuse. So in the same way that I came up with a over c, I could have used b over y and c over z, and I would have come up with b over c, just like I got a over c, I'll come up with b over c equals y over z. And I could have gone with a over b, and that equals x over y. And there's some other combinations I could have done, but we're not going to worry about those today. And what I want you to think about is if I wanted to use just this ratio, or I wanted to use just this ratio, or I wanted to use just this ratio. Well, that means that I would have to know something about these triangles. I couldn't just look at them and say, well, that over that is equal to something, and there's really nowhere to go from there. So what I want to do now is draw another right triangle. This will be, again, triangle ABC. And it'll have its little sides A, B, and C. Okay? When we talked about side A over side C, we said that side C was the hypotenuse. Or we talked about side C being the hypotenuse. And then we talked about side A being opposite from angle A. And that might be something you're not used to thinking about, because normally we just say that A and B are legs. And you've always heard with the Pythagorean theorem, people say, well, C is the long one, and it doesn't matter which one A and B is. Well, for what we're going to do, it does matter which one A and B is. So you always want to think about having a reference point. And for us, our reference point is going to be angle A. Okay, so if I'm standing at angle A, I'm looking out across this triangle, I would see that side A is opposite from angle A. And I would see that side B is not opposite from angle A, but side B is adjacent to angle A. Okay, if I redrew my same triangle exactly the same way, don't change a thing about it. Well, I just changed it to be red. Okay, don't change a thing about it. Here's B, here's our right angle C, here's A, C, B. The only thing I'm going to change about it is I'm going to make angle B my angle of reference. So if I'm standing at angle B, side C is still the hypotenuse, but now the opposite side is side B. So this would become opposite, and side A would be adjacent. Okay, so we're going to split our notes in half again right here. And what I want to do is look back at these ratios we wrote down. So when we put A over C, okay, A over C, we got that A over C by taking the opposite side from angle A and putting it over the hypotenuse. And that ratio is a specific ratio that always exists in any right triangle that has an angle that's the same measurement as this angle A. Okay, so that ratio is called the sine ratio. And the way we write it is like the word sin, but you say the word sine. And the sine of angle A equals the opposite side over the hypotenuse. And that just happens to be A over C. All right, then we look at this B over C. Well, B over C is when we took the adjacent side and we put it over the hypotenuse. That specific ratio is called the cosine ratio. So it's the cosine, C-O-S, of angle A, and it always equals the adjacent side over the hypotenuse, and in this case, it's equal to B over C. All right, then we get down to our last one that we're going to use, A over B. A over B is the ratio of the opposite side of angle A to the adjacent side from angle A. And that specific ratio is called the tangent ratio. We don't say tangent normally, or we do say tangent, I'm sorry. We say tangent, but we write the letter T-A-N. And the tangent of angle A is equal to the opposite side over the adjacent side, and that equals A over B. Okay, so this part right here this is what you want to learn. Okay, the letters are not always going to be the same. Okay, sometimes there'll be numbers, sometimes there'll be X's and Y's and Z's. So memorizing the letters is not going to do us any good. We want to memorize that the sine of an angle is the ratio of its opposite side to its hypotenuse. And I'll show you exactly what that looks like over here when we use angle B. So now we're going to come over and we're going to figure out what the sine of angle B equals. And you know that sine is opposite over hypotenuse. So the opposite of side B, or angle B, is side B. The hypotenuse didn't change if you notice. The only thing that changes is the adjacents and the opposites. The hypotenuse is always the hypotenuse. So the sine of angle B is B over C. The cosine of angle B, well, cosine is adjacent over hypotenuse, and that equals adjacent A over hypotenuse C. And the last one, the tangent of angle B, well, tangent of angle B is opposite over adjacent. And so that is B over A. Okay, so if you notice, our letters changed around So if these were numbers, they would have all been flipped over. But one thing you might notice is that the sine of angle A over C, equals the cosine of angle B, A over C. And then here the cosine of angle A, B over C, equals the sine of angle B. So it's just kind of neat that that works out like that. You don't need to worry about trying to memorize that. Just worry about this. If you notice, even though we got different answers, this part is exactly the same. Sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So one way that you may have heard to memorize this is to memorize the first letter of sine, opposite, and hypotenuse. Okay, so that's like this, S-O-H, and the next one will be C-A-H, and the last one will be T-O-A. And that spells, or it seems like it spells, some kind of maybe a Native American name, SOHCAHTOA, something like that. And if you memorize that and you write it down on your test or you write it down on your homeworks, it'll help you learn really quickly that S, sine, is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And you don't need to write this bottom part. This is all you'll need to memorize. So just take your time with it. It's not the easiest thing in the world, but it is one of the most useful things that you're ever going to learn in math. And it's also something that you're going to continue to use throughout your math career in high school and in college. So take your time with it. Come in, ask any questions if you have them.